Good morning all. This is Dr. D. Khalandar Basha, working as Associate Professor in Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today topic is Introduction to Internet of Things and under the course Principles of IoT. The slides are prepared by referring the textbook Internet of Things, a hands-on approach. Authors are Akshatdeep Baga and Vijay Madisetti, publication Universities Press. So, in the Principles of IoT subject, the first module deals with Introduction to Internet of Things, where we are going to study Introduction to Internet of Things, definitions, characteristics of IoT, physical design of IoT. Under this, we are going to see the protocols related to IoT, IoT communication models, and IoT communication APIs. Next, IoT enabled technologies. Under this, wireless sensor networks, cloud computing, big data analytics, communication protocols, embedded systems. Next, IoT levels and templates. Next, we have domain specific IoTs, where we are going to study about a few applications related to home, city, environment, energy, retail, logistics, agriculture, industry, health and lifestyle. Now, in this session, we will discuss about the introduction of Internet of Things, where we are going to see its introduction, definitions, and characteristics of IoT. IoT, that is Internet of Things, comprises things that have unique identities and are connected to the internet. The existing devices such as network computers or 4G enabled mobiles have a unique identification and are also connected to the internet. The focus of IoT in the configuration, control, and networking via the Internet of Things that are traditionally not associated with Internet. These include devices such as thermostats, utility meters, a Bluetooth connected headset, irrigation pumps, and sensors or control circuits for an electric car engine. So, Internet of Things is new revolution in the capabilities of the endpoints that are connected to the internet and is being driven by the advancements in capability in combination with lower costs in sensor networks, mobile devices, wireless communications, networking, and cloud technologies. The products include hardware and software components for IoT endpoints, hubs, or control centers of the IoT universe. The scope of IoT is not limited to just connecting the things like devices, appliances, or machines to the internet. Apart from that, the sensors which will act as a end nodes will sense the physical parameters like humidity, temperature. These will be sent onto the cloud through some communication protocols. In the cloud also, the stored or acquired data will be stored for further purpose or for doing the analysis by some analytics methods. And whenever you want to control some actuators, again these are the end output devices. So depending upon the analytics carried out, the control signals will be sent to the actuators. So IoT allows these things to communicate and exchange data while executing a meaningful applications. The data itself do not have a meaningful until it is context, contextualized, processed into a useful information. Applications on IoT networks extract and create information from lower data by filtering, processing, categorizing, condensing, and contextualizing the data. This information obtained is then organized and structured to infer the knowledge about the system and or its users, environment, and operation, and progresses towards its objectives, allowing a smarter performance as shown in the figure. For example, consider a series of raw sense measurements. A physical parameter we are having, let us consider 72, 45 or 84, 56. These are generated by a weather monitoring system which by themselves do not have any meaning or context. To give a meaning to this data, a context is added, which is in this example can be that each tuple in the data representation is the first argument is the temperature and the second one is humidity. So we are going to extract two sensor data. One is from a temperature sensor, the second one is from a humidity sensor. For every minute, we may be measuring this from the sensor. With this context added, we know the meaning or information of the measured data tuples. Further information is obtained by categorizing, condensing, or processing whatever the data which are sensed from the sensor. For example, the average temperature and humidity readings for last 5 minutes is obtained by averaging the last 5 data tuples. The next step is to organize the information and understand the relationships between the pieces of information to infer knowledge which can be put into action. For example, an alert is raised if the average temperature in the last 5 minutes exceeds 120 degrees Fahrenheit. And this alert may be conditioned on the user's geographical position as well. The applications of Internet of Things span a wide range of domains, including homes, cities, environment, energy systems, retail, logistics, industry, agriculture, health and lifestyle, and so many. So these are the various applications of IoT we can have, like home automation, health, agriculture, energy, retail, logistics. Like this, we can have multiple applications we can have on IoT. So for homes, IoT has several applications such as smart lighting that adopt the lighting suit for the ambient conditions, smart appliances that can be remotely monitored and controlled, installation, detection systems, smart smoke sensors, etc. For cities, IoT has applications such as smart parking system that provides status updates on available parking slots, smart lighting that help in saving energy, smart roads that provide information on driving conditions and structural health monitoring systems. For environment, IoT has applications such as weather monitoring, air and noise pollution, forest fire detection, and river flood detection systems. For energy systems, IoT applications such as smart grids, grid integration of renewable energy sources, and prognostic health management system. For retail domain, IoT applications include inventory management, smart payments, and smart vending machines. For agriculture domain, IoT has applications such as smart irrigation system for helping in saving water while enhancing the productivity and greenhouse control system. Industrial application of IoT includes mission diagnostics and prognosis system that help in predicting faults and determining the cause of faults and indoor air quality system. For health and lifestyle, IoT has applications such as health and fitness monitoring systems and wearable electronics. Now we will come to the definition of IoT. The Internet of Things has been defined as a dynamic global network infrastructure with self-controlling, configuring capabilities based on standard and interoperable communication protocols where physical and virtual things have identities, physical attributes, and virtual personalities and use intelligent interfaces and are seamlessly integrated into the information network, often communicate data associated with the users and their environment. The characteristics of IoT are: it is dynamic and self-adapting, self-configuration, interoperable communication protocol, unique identity. Self-adapting is depending upon the data which it is collected, actions according to the data which it is collected, it will be analyzed and it is going to make the changes for the desired specification achievement. Interoperable communication protocols. To communicate over a different communication protocols is possible and it is having a unique identity. Now we will see one characteristics in detail. Dynamic and self-adapting. IoT devices and system may have the capability to dynamically adapt with the changes in the context and take actions based on their operating conditions, user context or sensed environment. Example, consider a surveillance system comprising of a number of surveillance cameras. The surveillance cameras can adapt their mode based upon the weather condition, like either it may be a day or night. Cameras could switch from lower resolution to higher resolution modes when any motion is detected and alert nearby cameras to do the same. Self-configuring. IoT device may have self-configuring capabilities, allowing a large number of devices to work together to provide a certain functionality such as weather monitoring. These devices have the ability to configure themselves in association with IoT infrastructure, set up the networking and fetch latest software upgrades with minimal manual or user intervention. Next one is interoperable communication protocols. IoT devices may support a number of interoperable communication protocols and can communicate with each other and also with the infrastructure. Unique identity. Each IoT device has a unique identity and a unique identifier such as IP address or URI. IoT system may have intelligent interfaces which adapt based on the context, allow communicating with users and the environmental context. IoT device interfaces allow user to query the devices, monitor their status and control them remotely in association with the control, configuration and management infrastructure. Next is integrating into information network. IoT devices are usually integrated into the information network that allows them to communicate and exchange data with other devices and systems. IoT device can be dynamically discovered in the network or by other devices. The network and have the capability to describe themselves like characteristics to other devices or user applications. For example, a weather monitoring node described for monitoring capability to another connected node so that they can communicate and exchange the data. Integration into the information networks helps in making IoT system smarter due to the collective intelligence of the individual devices in collaboration with the infrastructure. Thus, the data from large number of connected sensors for weather monitoring, the IoT nodes will take the aggregate of all the sensor data from the various sensors and it will analyze to predict the weather conditions. Next, we will see the evolution of Internet of Things. The pre-internet where we are having the human to human interaction. It is fixed and mobile, telephony and SMS. Then we are added with some smart networks for achieving the internet of content using www through email, information and entertainment. Coming along with the smart IT platforms and services, we have Internet of Service by using Web 2.0, which is having e-productivity and e-commerce. For this, the smartphones and appliances added for Internet of People using the social media like Skype, Facebook, YouTube and Twitter. For this, along the smart devices, objects and tags, we got Internet of Things where it is communicating now mission to mission like identification, tracking, monitoring and metering, semantically structured and shared data. Now for this, the smart data and ambient context also can be added. The term Internet of Things was first used in 1999 by British technology pioneer Kevin Austin to describe a system in which objects in the physical would be connected to the internet by sensors. He coined the term to illustrate the power of connecting a radio frequency identification, that is RFID tags, used to incorporate supply chains to the internet in order to count and tracking goods without the need of human intervention. By the late 1970s, for example, the systems for remotely monitoring meters on the electrically grid via telephone lines were already in commercial use. In the 1990s, advanced in wireless technology is allowed where the mission to mission, enterprise and industrial solution for equipment monitoring and operation to become widespread. Many of these early mission to mission solutions, however, were based on closed purpose, built networks and proprietary or industry. So, in this session, we are discussed an introduction to Internet of Things. What is meant by Internet of Things? What are the various elements and applications are existing in Internet of Things? Few applications in various fields, and what are the applications we can apply on each and every field we are just listed. Then the definition and characteristics of IoT, followed by evolution of internet we have discussed. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.